All right, in today's lesson, we're going to look at rationalizing the denominator. So we're going to look at getting expressions like this. In fact, this will be our final example in today's lesson of being able to rationalize the denominator. And what they mean by that is get rid of the roots on the bottom. So let's start off with some basic examples of rationalizing the denominator, i.e. the bottom of our expression. In the first example here, we want to rationalize the denominator. So I want to get rid of that root of 2. So what you do in this situation is we're going to multiply the top and bottom of this expression by root 2 over root 2. And by doing so, you're essentially just multiplying by 1. Therefore, when I multiply the top and bottom by root 2 over root 2, we have here the numerator will become 3 root 2, and the denominator here will just simplify to become a 2. In general, if you take the root of x times the root of x, as you know in exponential form, that'll be x to the 1/2 times x to the 1/2. And whenever you multiply with the same base, you add the exponents, in which case this just becomes an x. So in this situation here, we have 3 root 2 is equivalent to 3 root 2 over 2. And now we've rationalized the denominator, gotten rid of that root sign on the bottom. Let's take a look at another example. In the next example here, again, we want to get rid of these roots on the bottom. Now I can't just multiply across by root 3 or root 2 individually. And if I were to multiply across, for instance, by root 3 plus root 2, a lot of times students will think that will be like our next sort of step here. If you multiply these two out, you will take the root 3 times root 3, that'll just become a 3, and you'll take the root 2 times root 2, that'll cancel the roots off and just become a 2. However, when you take the root 3 times 2 and take the root 2 times root 3, you'll generate root 6 for both of those, and you'll just have another root in the bottom. So instead of doing addition, what you want to do is you want to force a subtraction. And the reason for that is now you forced a difference of squares. And if you recall the formula for difference of squares, and your difference of squares formula tells you if you take x minus y times x plus y, that's equivalent to x squared minus y squared. So therefore, if this is my x and this is my y, x plus y times x minus y is the same thing as just root 3 squared minus root 2 squared, which in this case will be 3 minus 2, which is 1. Let's take a look at the math. All right, you can see here I went ahead and did that difference of squares formula we forced here. And like discussed here, this became a 3 and this became a 2. Subtracting it up, we got a difference of 1. So the entire expression ended up being 2 times root 3 minus root 2. So again, we're still multiplying by 1, but by this technique here, you're forcing a difference of squares, and that will rationalize your denominator. And our simplified expression, which is equivalent, is equal to this. So again, these two are equivalent, but in this situation here, we've now rationalized the denominator. Let's take a look at another example. In the next example here, it's the same idea as the previous one, except for we're going to be multiplying by 2 root 2 plus 1 on the top and bottom. And again, by doing that, we've now created an x minus y and x plus y. So the top, let's leave it unchanged for now. We'll have to expand it out later. The bottom, like we discussed, is going to be 2 root 2 squared minus 1 squared. So let's go ahead and we'll expand the top out using FOIL. So again, I'll go through FOIL here, expand out the top, and I'll also square this. And by doing so, we get the following. All right, so I went ahead and did my math here on the top. You'll notice here I had root 2 times 2 root 2. The root 2's come together and cancel and just become a 2. And then you have your 2 from before as well. So this became 2 times 2. Then I had root 2 times 1, which is just root 2. Then I went ahead and took 1 times 2 root 2, which is just 2 root 2. And lastly, 1 times 1 is just 1. The bottom becomes, like we discussed, your x squared minus your y squared. So if I square this term here, when you're squaring a product of numbers, you can that square, that power is distributed to each one. So in this case here, 2 squared is 4, and root 2 squared is just 2. That root cancels. 1 squared is obviously equal to 1. So continuing this question here, we can clean this up. I can collect up like terms. So I have my 4 here and I have my 1 here. That can become a 5. And in this situation here, I have 1 of these root 2's and I have another 2 of these 2 root 2's. Don't forget there's a 1 sitting out in front here. So putting that together, I end up having 3 of them. So this ends up being 5 plus 3 root 2. And the bottom becomes over 7 as you have 8 minus 1. So now you'll notice here I've now rationalized the denominator, i.e. we've gotten rid of the root symbol on the bottom. We've found an equivalent expression for our original question. Let's take a look at another example. In the last and final example here, the same idea, we want to rationalize that denominator, but now we have three terms. So the technique with this situation is what we're going to do is we're going to group these together and consider that as one term. And I'm going to multiply by 2 root 5 minus, don't forget your brackets, this expression. So by doing this, we at least can cancel some of the roots on the bottom, but you won't be able to do them all at once. So now if I apply this technique here, we still have a difference of squares we forced. The numerator I'm going to leave unchanged. Let's just leave it as it's written here. I'm going to go ahead and distribute that minus sign into here because we're going to have to expand this out later. Now again, this becomes my x plus y and x minus y. So now this becomes 2 root 5 squared minus the root of 3 plus the root of 2 squared. I'll go ahead and distribute this root of 3 into this trinomial, and I'll clean up the bottom as well. So this becomes, so simplifying this up a bit, I distribute the root of 3 into the brackets here. I end up getting, in this situation, I ended up getting root 3 times 2 root 5 became 2 root 15. Just put the roots together. Here I had root 3 times root 3 is just 3. Then I had root 3 times root 2 is root 6. Again, that exponent gets distributed to both these terms. That becomes 4 times 5. Then we square the first times second times 2, and square the last. So let's go ahead and distribute the minus sign and simplify. All right, continuing this lengthy question here, you can see I went ahead and distribute the minus sign, clean up the bottom. We have a much simpler expression now to work with. I'm still not done. I need to rationalize that denominator. So now I'm going to go ahead and multiply by 15 plus 2 root 6 on the top and bottom. Doing so, we get the following. So going ahead and multiplying by 15 plus 2 root 6, again, you get your 15 squared minus 2 root 6 squared. I'm going to go ahead and expand out this entire top here and simplify. Doing so, we get the following. All right, now I went ahead and expanded everything out. I then went ahead and collected like terms. You'll notice the 22 minus 4 times 24 reduces to become 201. Collecting like terms here. As I collected like terms, our expression reduced to become the following. I made the observation I could divide a 3 out of the top and bottom. By dividing a 3 out of the top and bottom, these 3's cancel, and we have our final answer as 10 root 15 minus 7 root 6 plus 4 root 10 minus 19, all divided by 67. And that concludes today's lesson on rationalizing the denominator.